Okay, here is an interesting problem. The number of rational numbers that lie between half and 4 by 5 is dash. How much? So the options are 2, 1, 3 and infinitely many. So it's very interesting. So some may try like this. So you have half and 4 by 5. So they may observe something that numerator and denominator differs by 1. Here also the same. So they may think that in between numbers are 2 by 3 and 3 by 4 and possibly may think that it's 2. Or some might try to get the equivalent fraction. So 2 and 5 are the denominators. The LCM is 10. So half can be written as 5 by 10 and 4 by 5 can be written as say 8 by 10. So you can see that 5 by 10 and 8 by 10 you can insert two fractions 6 by 10 and say 7 by 10. So you have two such forms but with 10 as denominator. So again the answer could be 2. So there are many ways it can work out, but you must understand that when you are going to write say half is equal to 2 by 4, 3 by 6, 4 by 8 and so on. So in fact I can write this as even say something like this or maybe bigger and so on. So there is no ending. There are infinitely many equivalent fractions. Similarly 4 by 5 can be written as say 8 by 10, 12 by 15, 16 by 20. So the numerator and denominator may change. Again I can have say 4 followed by any number of those, the same with 5, as many zeros with 4. So this is also 4 by 5. So the point is we should not see only this as half and 4 by 5 or only the LCM's denominator. So in fact we can write this half as 5 by 10 and 4 by 5 as say 8 by 10. If you are going to see that 6 by 10 and 7 by 10 are the two rational numbers in between, so I can write this as say 50 by 100 and this is 80 by 100. Now I can see that I can plug in. If I am going to write this as say 50 by 100 and this is 80 by 100, now I see more gaps. I can put 51 by 100 is definitely more than 50 by 100, 52 by 100 is also more, until I can go till 79 by 100 and all these rational numbers are in between 50 by 100 and 80 by 100, but I have more numbers here. You can see from 51 by 100 to 79 by 100 there are more than 2, so the number is increasing. In fact, if you are going to convert this to 500 by 1000 and this is 800 by 1000, then you see that this is going to be say 500 by 1000, which is same as half, and this is going to be say 800 by 1000, and you have 501 by 1000, 502 by 1000 and so on. I can even have 799 by 1000, which is more than 500 by 1000 and less than. So now you can see there is more numbers you are getting. Therefore point is just for illustration I have been explaining like that. So one can see that whenever you have some denominator and you are able to maintain a denominator, a large denominator with an equivalent fraction, you see more fractions are plugged in. So if I go to the next level, some more fractions, some more rational numbers will be plugged in. Therefore how much you can increase the denominator, that is uncountable, so you can keep on increasing and therefore you can always plug in the rational numbers. And also if you are going to take two rational numbers, I can find another number in between. So for any two rational numbers a and b, you know a plus b by 2 lie between a and b. If they are different, then this is also different. So this is a very important property. Therefore if you are going to find this, we are going to find something in between and those two are different, again I can find in between, and this process continues on and on. Therefore you can keep on finding rational numbers between two rational numbers. You can go by the average method and you can see that there are actually infinitely many rational numbers between two rational numbers. So that's the key point. So don't just see that some denominator like 10 or maybe some other pattern and see that these are the only numbers. Therefore, the number of rational numbers lying between half and 4 by 4 or general two different rational numbers is going to be infinitely many. So that is your answer.